Okay, so today we will start with the life cycle of a star, and there are two important concepts we have to discuss in life cycle of a star. The first one is that how the formation of the star take place, right? So how the formation of star take place. Basically, in this chart, you can see there is a whole formation or there is a whole life cycle of a star. It is started from giant gas cloud, or which is also called nebulae in short form. So we know that gravity is also like exists in planets in the solar system also. So same if there is a giant gas cloud, or like a simple, we in simple words we can say if there is a cloud of gas and dust. So due to gravity, that it starts to move like with the direction of the gravity. So first of all, if we talk about the formation of a star, that how stars actually form. So the formation of star take place like this. The first step, just like you can see mentioned over here, there is a giant gas cloud. So a large cloud of gas and dust collapse under own gravitational field. And this is also like very important topic in this chapter. In exam, you will find questions related to this formation of the star or different stages related to the star. So, and it is also very simple and interesting because with this picture, you will get each step, and the concepts are just like the normal forces concepts. So that's why it is also easy. Now we got one idea of the force, that gravitational force is acting definitely inside, because that is force of attraction. So this gas and dust clouds are going to be collapsed because of gravitational field. Now, what actually happens after this? So the second step, you can see it is protostar. So the second stage is called protostar. So the second step is called a protostar. So let's suppose if they ask how protostar forms, so that is very simple. When large cloud of gas and dust particle collapse under its own gravitational force or field, so that is called protostar. That stage is called protostar. Simple. Now, in the third phase, actually what happens, this collapse continues because gravitational field is continuously acting on those dust particle and the large cloud of gases. So this collapse will continue to go on, and the temperature of the core rises because in the center we have core just like the earth planet. So the temperature of the core starts to increase. So now in the third step, what happens, that this collapse continues to take place, and temperature of core rises until it is large enough to cause fusion reaction. Because in the concept of the stars, we discussed that fusion reaction take place. So how this fusion reaction actually starts? So this is the process, that how fusion reaction take place. So due to the gravitational field, the temperature of the core continues to rise and until it reaches a specific value. So at that specific value, the fusion reaction starts. And what happens in the fusion reaction, we already discussed that hydrogen converts into helium. So hydrogen turns into helium. Okay. So from these four steps, you can simply identify that how this fusion reaction starts. And now this is also called the formation of the star. And now how the star will be in a stable form. So that is also very simple. So the fifth step explains you about the idea that how stars remain stable for some time or whatever the life of that star will be. So basically, once the fusion reaction starts, so star stops collapsing and heat produced. Because now fusion reaction starts and one reaction also takes place. So gravity tries to again collapse that clouds and the particles in towards the center, but due to the fusion reaction, there is now enough energy, so gravity will not able to collapse those particles or those clouds of the dust into the core. So now there is a concept of equal and opposite forces, right? Any confusion? So let's suppose if this is the formation surface of the star. So due to gravity, the force is acting towards the center, okay? But due to this fusion reaction, the force of gravity is not able to perform this part anymore, just like the before the fusion reaction. So this fusion reaction helps the star or the surface of the star to like be in a stable state as compared to the previous one. So once the fusion begins, star stops to collapsing and heat produced. So the heat produced due to fission reaction generates enough pressure from inside to balance this gravitational force. So in this way, it is just like a tug of war game. So now two different quantities or two different concepts are acting in opposite directions. So that's why now the surface of that cloud or the dust particles are not collapsing inside because of gravitational field. Okay. So this is the concept for the formation of a star. Okay. Any confusion in the formation of the star concept?
No, sir.
Okay. Okay, now in this chart, you can see there are further more stages. Like there is low and medium mass star, which is actually sun, and the second one is the high mass massive star. So now you can see this second stage is called main sequence. That's why we used to write over here our sun is a main sequence star. So basically, this is the second stage, which is like a stable stage. So now we have to discuss how this low and medium mass and how this high massive mass star actually form and how it converts into the red supergiant. So the next step is about this. So the next concept is related to the life cycle. So now we are going to talk about the life cycle of a star. So the very first point in this life cycle of the star, definitely after some time, this fusion reaction will going to be stopped or the fuel for the fusion reaction will be run out because hydrogen is the fuel for this fusion reaction. But after some time, hydrogen will not no more available to continue that fusion reaction. So what happens next? So basically, when a star begins to run out the hydrogen for fusion, because it is natural that definitely after some time this hydrogen is going to be run out and there will be no fuel for the fusion reaction. So again, what happens? Just if you compare from the previous formation of the star steps, so now again the opposite force which is balancing the gravitational field is again going to be decrease. So again what happens? Again gravitational field will be dominant and that is again it starts to attract. Okay, so this is the concept. So when the hydrogen fuel is going to be run out, so the outward expansion force is not enough to counter gravitational field. So when this hydrogen is no more available and the outward expansion force is not enough to balance that gravitational field, so what happens? The core of the star gets denser. So in the second step, the core of the star gets denser. And why it is getting denser? Very simple. You we take the reference from the first point, because a large cloud of gas and dust collapse. So when they collapse, so definitely the core becomes highly dense, highly populated. So that's why it becomes denser as compared to the first stage, and it starts to. So basically, hydrogen converts into helium. Hydrogen combines and form helium. So now helium is available. So actually, when the core of the star gets denser, right? So heavy nuclei are there. So the core starts to convert, or the core starts to just change the form of helium into other heavier elements, right? So the core of the star gets denser and it starts to fuse helium into other heavier elements, right? Any confusion? So basically, now the opposite force or the counter force is not enough to balance the gravitational field. So actually what happening, that the helium element, which is actually combined from the hydrogen isotopes on the star, so that it starts to fuse into, now basically the helium atom continues the fusion reaction and it converts into a heavier element. Just like in this diagram, you can see the red giant and super red giant. So they are like massive in mass. So we start from the dust and the cloud, and now it is going to be converting into a heavier, a denser, and a solid material, right? So hydrogen is a light element and it converts into helium. Helium is a heavy nucleus. So that further helium nucleus combines and it converts into more heavier elements as compared to the previous one. Now, what happens in the third part? So in the third part, the heat produced, because helium starts to continue the fusion reaction. So again, heat will produce. So now the heat produced and it causes the outer hydrogen to fuse and consume, and heat causes the expansion to accelerate. And finally, as we observe in the chart, that it converts into the main sequence star. So now main sequence star turns into a red giant, or red supergiant. Okay, so this is now the next stage, which actually converts from the main sequence into the red giant or red supergiant. So now we are in the third stage, the old age. Now, the star is close to the death of its life cycle, because we are just writing the process. We are not talking about their ages, their lifetime, and their timeline. We are just talking about their whole procedure, how it takes place. So you can see now, after the red giant, or after the super red giant, it is going to be converted into the planetary nebula or the supernova, and then finally into black dark or into black holes. So this is the final stage in which the life cycle of the star is going to be end up. And there are two different lines from which we are going to convert into the death of the star. The first one is from the red giant, that is from the sun, for the sun actually, and the second one is from the super red giant. So from the direction of the super red giant, we converts the star into neutron star or the black hole. So there are two possibilities. So let's see how we actually discuss that part. So now we are going to talk about the final stage. Actually, the final stage is the death of a medium mass star. So now we are going to talk about the medium mass star, that is actually the sun. So what happens? The first step is, again the scenario is same. The hydrogen fuel is actually run out. So the hydrogen fuel in the core begins to run out. And the second step is, the heavier elements in the core begins to fuse. Because when hydrogen is not available, so definitely the elements heavier than the hydrogen starts to fuse, and the temperature of the core rises. And then we have a third step. Now the temperature actually increases. So this high temperature causes the hydrogen on the surface to fuse as well into helium. And the fourth step is, now core becomes denser, and when core becomes denser and it is strong gravitational field, keeps its collapsing, gravitational field keeps it collapsing. So what happened in the fifth stage? Now it is going to be converted into red giant. And how it converts into the red giant? The gases on the surface expands, and since there is no more fusion reaction on the surface, so it will be cooled down due to large expansion. So the temperature decreases, and converts into a red giant. So now when it converts into a red giant, the next part, that this red giant is going to be converted into planetary nebulae. So how it converts into the nebulae? We already discussed about the fifth stage. Now how it converts into the sixth one. So at a certain point, when temperature is extremely high, so when temperature is extremely high in the core, because the temperature on the surface is low and it is expanding. So surface is expanding, but the temperature of the core is very high. So there will be like an explosion takes place, just like in the normal bomb theory, that when the temperature is very high, so bomb starts to like explode over there. So the same happens over here, that when the temperature of the core increases extremely high, so an explosion causes, and it will also affect the gases on the surface. So those gases will be add up into the outer space. So that gas will add up into the outer space. And when the gas expands, so that expansion of the gas is actually called planetary nebulae. And that part of the gas which after the expulsion of the surface into the space left out, so that part is called planetary nebulae. So remaining part of the star is called actually planetary nebulae. So basically the outward explosion force is no more working, only the gravitational field is working. So that's why, due to the high temperature of the core and the internal force acting on the surface, it is going to be converted into white dwarf. And why it is white dwarf? Because the temperature is very high. So it is called white due to high temperature. And finally, when fusion reactions almost or like it's about to end, so when the fusion reaction comes to an end, they turn into black dwarfs. And these dwarfs actually contains heavier elements like iron. So this is the concept of a small mass star just like the sun. So let's suppose if you just want to study about the whole life cycle of the sun. So this is the whole life cycle of the sun, and it is going to be convert finally into uh, the black dwarfs and how it actually takes place. So we study from the start. Basically, it is depending on the fusion reactions, that how the fusion reactions or how long that fusion reaction actually works for. Then, so after that, it is going to convert its shape and it is going towards the death of the star. And if we also compare it with the death of a high mass star, opposite to the mass or opposite like the example of the sun. So if we talk about the stars, so the first point that takes place, so how much the mass of this type of red giants are greater. So basically it is 8 more times greater than the mass of the sun. So that is why it is called high mass star, because they have masses more than 8 times that of the sun. So this is the first point. And what will be the change because of this greater mass? Because definitely it has greater mass, so there will be some changes in this as compared to the previous less mass star. So the fusion reaction will be take place at greater rate as compared to the first stage or the first category of a small mass star. So the fusion reaction takes place at a higher rate. And the third point is, again, the heat produces from this fusion reaction will be greater as compared to the small mass star. So the heat produced causes surface hydrogen to fuse as well, and again expand. So basically process is same. The first difference that we observe in this, that the mass is greater. So due to the greater mass, the fusion reaction takes place at a greater rate. And again, the process is same. Heat produces uh, on the surface of the star because of hydrogen, and the hydrogen also starts to fuse on the surface, and it starts to expand just like in the previous concept. And from the center, we know due to high temperature, the core starts to collapse further as compared to the previous stage. So the core collapses further due to extra gravitational force. So these are the three stages for this concept. And the next stage is, so now it is going to be converted into a supergiant. The star turns into a red supergiant, and it is called a red supergiant again because of large size, because it also have a large mass. So that's why it is called a red supergiant. And in the fifth part, just like in the small mass converts into the planetary nebula, but this converts into some different concept, into a different category. So finally, when elements fuse, and it start producing iron, so when it starts producing iron, just like the previous small mass star, the fusion reaction ends in the form of a large explosion, and this will also explodes, and it explodes into supernova. So this is a different category. And in that chart, if you observe one thing, that this super red giant converts into supernova, and that supernova converts into neutron star or a black hole. So there are two possibilities, but in only red giant, it converts into planetary nebulae, then white dwarf and black dwarf. So these are the possibilities for the red giant. But in red supergiant, there are two possibilities to convert into the final stage. So let's see how it takes place. So the next stage is definitely after this explosion, we got energy and light. So the energy and light produced is very high due to such that so the energy and the light produces very much high such that even iron starts to fuse into heavier element. So we started from the gas, hydrogen, it fuses into helium, then helium fuses into more heavy elements and it converts into the iron, and further iron also starts to fuse into further more heavy elements. So this light energy and the thermal energy is so much high that iron starts to fuse into further heavier element which expels in outer space as clouds or nebula. So this is the concept for the super red giant or the high mass star as compared to the small mass star. And why this neutron star formed, or how this neutron star formed? We have two different names over here, either neutron star or black hole. So basically, let's suppose if the red supergiant or the mass of the red supergiant is small, if this is small, so basically when red supergiant is small, so it converts into the neutron star. And it means there is no fusion reaction in this uh, whole process takes place just like the normal one. And a large amount of heat is radiated So that's why it converts into the neutron star. And if it was large, just like again dense, so it converts into the black hole. So these are two different possibilities for this red supergiant. So we will also write them, and that will be the end of the death of both types of the stars. So the first part is if red supergiant was small, so neutron star is formed. So neutron star is formed that has no fusion reaction. So just like the normal condition of the supermass star, the nuclear fusion reaction take place. But if the red supergiant was small, so it converts into the neutron star, and there is no fusion reaction takes place, but a large amount of heat, but a large amount of heat is being radiated. And again, it converts into heavier elements. So when it converts into a heavier element, and it also starts to spin at very high rate. Generating radioactive pulse. So this is the concept of the neutron star. And if we talk about that black hole, so how actually black holes form, that is the second possibility. If red supergiant is large, if red supergiant was large, the extremely dense core turns into a black hole, and not even light can escape from it. So this is the life cycle and the death of the both types of star, the small mass star and a large or a heavy mass star. And one thing you observe that all processes are very much linked to each other. First of all, definitely we have to start with the fusion reaction, and that fusion takes place because of the hydrogen, and that hydrogen converts into helium, and further helium will continue, and after some time it will be this reaction will takes place on the surface, and the temperature of the core starts to further increase, but the temperature of the surface starts to decrease. And how these different stages takes place, so we observe all the things in different scenarios, that how the formation and the death of the star takes place, and this is the concept related to the stars.